Hello everyone, today we will bring you a brief introduction to the new features related to data lake analytics in StarRocks version 2.5. In this introduction, we will focus on 4 topics: more comprehensive SQL use cases, enhanced query performance, out-of-the-box user experience, and more powerful public cloud ecosystem integration. For Apache Hudi External Catalog, StarRocks officially supports querying merge-on-read tables in version 2.5. Also, 2 query modes are provided: snapshot query and red-optimized query. With this new feature, StarRocks can better support real-time data lake analytics scenarios, such as analyzing real-time data ingested from Apache Flink CDC to Apache Hudi. Starting from version 2.5, StarRocks provides support for complex data types, map and STRUCT, for Apache Hive External Catalog. With this added support, StarRocks can be used in more complex and diverse DLA scenarios, and also help users to seamlessly migrate existing SQL workloads to StarRocks. There are also plans to provide native support for map STRUCT data types in StarRocks internal OLAP tables in the future. The next feature is the Delta Lake Catalog. There have been plenty of feedbacks from StarRocks users who want to integrate StarRocks deeper with the Spark ecosystem. For example, we can use StarRocks to directly query and analyze data from upstream Databricks batch processing jobs. With the addition of the Delta Lake Catalog, StarRocks has full support for 3 of the most popular table formats for data lakes: Apache Hudi, Apache Iceberg, and Delta Lake. The next feature is the File External Table. Prior to StarRocks version 2.5, if StarRocks users wanted to analyze data files in a DFS or object storage, they could only do so by ingesting them into StarRocks. Starting from version 2.5, you can create a File External Table with the file path, file format, and schema information to query and analyze files directly without any data migration. With this feature, in addition to easier analysis of files, the transformation of files is also easier, avoiding the extra cost that comes with data migration. Prior to StarRocks version 2.5, if the Apache Hive table has a new partition or a change in data within a partition, such as an insert-overwrite partition, it is required for users to manually perform refresh external partition on a specific partition inside StarRocks to complete the metadata synchronization inside StarRocks. Starting from StarRocks version 2.5, StarRocks is able to detect newly added partitions at query, thus ensuring the correctness of the query results. When data is updated in existing Apache Hive partitions, there is no longer need to manually refresh the data for a specific partition. You only need to run refresh external table for the entire Apache Hive table to ensure the correctness of StarRocks query results, providing an out-of-box experience for the entire data synchronization process. The next feature is block cache. In many ad hoc query scenarios, sometimes it is needed to perform a full table scan on a large amount of historical data. The I/O cost is significant and cannot be directly optimized/avoided with the cost-based optimizer or vectorized execution engine. Starting from version 2.5, StarRocks has introduced a built-in cache for raw files on object storage, specifically to cache the split original data, such as a Parquet file, on the BE node. Additionally, when caching, we are able to support using a combination of memory and local disk as storage media. When querying hot data, this approach can completely avoid the cost of I/O. We have tested with an ideal scenario where we have 100% cache hit rate. The query performance of the same table is already at the same level as the OLAP table inside StarRocks. And the whole caching system is introduced without any external dependencies, which is truly out of the box for users. This brings users a number of analytic performance positions on the data lake. StarRocks version 2.4 introduced a newly designed asynchronous Materialized view. In StarRocks version 2.5, StarRocks supports building Materialized views directly on the data lake. When you create a Materialized view, You only need to define the logic of data processing and the time interval of automatic refresh, for example, 1 day. The materialized view is automatically refreshed and persisted in StarRocks internal storage's local disk. Considering the high cost of full table scans when querying data lakes, routinely performing such scans introduces unnecessary network and storage I/O overhead. Therefore, for scenarios like querying an Apache Hive table, in version 2.5, Materialized views also provided support for users to limit the number of scan partitions at creation. This is a way to control the additional hardware resource overhead during routine job execution. The last feature is the support for Amazon Glue. Amazon Glue is a self-managed metastore service provided by AWS that is natively compatible with the Apache Hive metastore, providing users with out-of-box data management and automatic file schema detection capabilities. In order to bring a ready-to-use lake analytics experience to public cloud users, StarRocks officially integrated Amazon Glue in this version as the metastore for data lake analytics. Through testing, StarRocks is now able to support analysis and query of multiple mainstream table formats for data lakes, such as Apache Hudi, Apache Iceberg, Apache Hive, and Delta Lake. If you're eager to learn more, welcome to join the StarRocks community. We're always active on social media and in our Slack channel. Our website is also updated frequently with new use cases, feature releases, and technical deep dives. For a cloud solution or dedicated technical support, please visit our website at CelerData.com for more information. Thank you for tuning in, and we'll see you in our next video.